Okay, so this is how you magnetize things. Okay, the first way to magnetize things. Here's the basic idea. In this picture here, this is supposed to be an unmagnetized thing on the left. A is like unmagnetized or random. And so the idea is that there are these little chunks of iron called domains. And these domains have a preference. They're sort of like a voting block. All these guys vote together, right? Okay. And so these guys are all going to switch at the same time. They're like little pieces of crystal in the metal. Okay. And they're much smaller than this, or maybe this is a very small magnet, right? But in this one, they're all sort of oriented more or less randomly, yes? Okay. In this one, there's a slight preference for the bottom being the North Pole. Yeah? You can see that there's a slight preference. And the better the magnet is, the more the domains are aligned. Okay? And there are lots of ways that you can rearrange these domains, but they all boil down to basically shocking it somehow. Okay? So then there's two ways I'm going to show you here. I'm going to shock a magnet mechanically, okay, and then I'm also going to shock it electrically. Okay, and the electric one involves fire, and the other one just involves using a hammer. Okay, so here we go. I always got to remember to put the glasses on first. You know it's good if I need the safety glasses and the hammer. So if Dinadu had been sleeping for this, I think he would have woken up. This would have got his attention. Okay. I know. Okay, there's the compass. And one end of this metal bar is the North Pole and one end's the South Pole. So let's figure it out. That end is the South Pole because the North Pole likes it, right? And this end is the North Pole. The taped end is the North Pole, correct? So let's make it the South Pole. Now, what you need to do this is you need an external magnetic field. The Earth's magnetic field, yes? You need to take the metal bar and line it up with the field, and then you just need to beat on it. Okay? So there's north. Magnetic north is 17 degrees that way, and it's slightly down, like that. Okay? And this end will line up to be the North Pole end, yes? Are we ready for this? Okay, are we ready? Do you think that's enough? No, I better hit it some more. Oh, none of that. Okay, I think that's enough. Now, this end was the South Pole. It is now the North Pole. This end was the North Pole. It is now South Pole. You guys think it's just random though, so let's try it again. Let's make this end, which is now the South Pole, let's make it the North Pole. Oh, I forgot to scream. Ah! I think that's enough. I don't know. We'll see. Are we ready? This should be the North Pole now. Let's see if it is. I need some applause. There we go. All righty. The second way involves shocking it electrically. And so what I'm going to do is I'm going to use a tremendous magnetic field, and to generate the magnetic field I'm basically going to knock out all of the power in all of Tualatin. No, I'm just kidding. I'm just kidding. It sounded better when I said that, but okay. Now, to do this, what I'm going to do, first I have to find something that is not magnetized, and sometimes this is tricky. So let's see, is this magnetized? Yes, it is, darn. Is this one magnetized? Yes, it is. Darn. Is this one magnetized? Yes. Is this one magnetized? No, it is not magnetized. Okay, now I will place it inside the coil, and what I'm going to do is I'm going to make a dead short. Okay, now the voltage coming out of the wall is going positive 170, negative 170, positive 170, negative 170. Okay, like this, right? So this magnet is going to go north, south, 60 times a second, yes? Okay, now what it's really going to do, by the way, is it's going to go either to the north or the south. I can never tell when I'm going to turn it on, okay? But it's going to do one of those. It's going to head toward north or toward south, and then it's going to, I've got a little fuse, and the fuse is going to vaporize, and the magnetic field is going to, boom, just go away just like that. And those domains are going to go, ah! and be stuck. This is called hysteresis, by the way. Okay, they're not going to go back to the original spot because they've been awkwardly pointed this way, and then the magnetic field's been taken away, and they just they retain that magnetic field. Okay, so they're going to kind of go whoop in one direction or the other. And by the way, the problem with this is that I don't know whether I'm going to make it a north pole or south pole. Okay, so it is unplugged because these, by the way, are just like. Don't try this at home. Okay. Now this is going to like make an arc welding type spark, so don't look right at that. Do not look right at it. Are you ready? I looked at it. Oh, oh! I'm on fire. All right. I am turning it off. I am unplugging it. These are all safety things. Are we ready? Is it now a magnet? I hope so. Yay! It is now a magnet. Now, how do I unmagnetize it? Well, what I do is the opposite of that. I stick it in this coil, and I'm going to make it go north, south, north, south, north, south, north, south, and I'm going to turn the voltage, the alternating current voltage, gradually down. Now, what's going to happen is the domains are going to drop out of that north-south dance randomly. I don't know what determines when they drop out. It might be their size or something like that. But they're just going to drop out randomly, which will leave them like this guy on the left. Okay? So let's try that. Let's stick this guy in here. And what I do is I stick that in there like that, and I turn it to 0 to 16 volts, and then I turn it up until I can feel the metal shaking inside here. And then just a little bit higher. Not so high that I like sparks arc onto my hand. Ouch. Okay, now I'm turning it down very gradually, and those domains are just random. It's like you turn the music down at a dance. People will randomly stop dancing. And just imagine that they just freeze where they are, and you've got an accurate picture of what's going on here. Are we ready? Okay, are we ready? Here it is. Is it magnetized? No, it is not. Yay. All right.
Now remagnetize it.
Now let's demagnetize this guy. We'll try another guy here. So here we go. This guy was magnetized, and now I'm turning it down. Another clue that I've turned it up high enough is that the magnet gets warm, you know. Okay, I'm turning it down. It is now not a magnet. It was. I don't know if you recall. Okay, I'm checking this cord is unplugged. Important safety tip there. Because that would be very bad to grab these when it's plugged in. Okay. Is it off? Yes, it is. Turn the lights off. All right. Are we ready? Yeah, you can look at it. Don't look at it. Look at it. Don't look at it. Oh! Ooh, look at that. Wow, I've never seen that. I call that one the hopping ember. It left little, it's really cool, it left little burn marks in the counter. I've never seen that before. In 20 years, I've never seen it do that before. I mean, little hopping marks. You can look at it when you come to get your thing. Okay, is it magnetized? It better be after all that. That one's real good. Like, Sometimes magnetic screwdrivers are handy because they're like, the screws will stick to them. Okay. Sometimes they're not, you know. Yeah, it's like, dang, like that. Yeah.
So after you touch the things that you're picking up with the magnet, do they become magnetized?
No, not so much. This is not. It takes a little more than that. But if it hangs out in the same cupboard, it can be. All right. Okay, so the first one, remember X doesn't mean anything. It just means cross product. So that's